Ismail is here. Today we're going to start the lesson 3.3 properties of logarithm. This is a simple, easy lesson. It just helps you to apply the properties, and we have one new properties. This properties can be used when the calculator is not allowed, okay? But I'm going to allow the calculator for all the situation. But we are going to learn it. Now, let's start with the first thing here, properties of logarithm. Before we go to the properties of logarithm, let's summarize what's the properties of the exponential equation that we already learned before. So as you can see, when you have base multiplied with a base, okay, with the different power of x and y, what we do with the bases? The bases are b together, so it will be one base, and we just add the power. So it will be same base x plus y. The same thing when the quotient property b over b to the power x over y, so it will be bx minus y. Then the power property. Power property is when you have power to the power. So as you can see, power to the power, what we do with these two power, we multiply them. So it will be to the power x times y. The same idea of this property, it's going to work on the logarithm. Okay, so first thing, when I have logarithm base b x times y. Okay, so for example, log, okay, base 5x. 5x are multiplied with each other. How can I simplify this to 5x? I can split the x alone with the log, and I can split y alone also with the log. So this is what you can see here. Log bx plus log by. So the same thing, I can split 5 with x, so it will be log base b 5 alone plus log base b x. So this is the first formula, which is called a product property. Now the quotient property, when only log 5, for example, the same example, 5 divided by the x. So when there are x and y divided over each other, so we just minus the log. So it's equal log base 5 minus log base x or y or whatever. Okay, so okay, the question here, the example, so x. Okay, now the last one is the power property. So when you have a log base x to the power of any number, we can take this number next before the log. So this is what you can see here. So for example, when I have log base b x to the power of 6, so I can take this 6 before the log, so it will be 6 log base x. So this is how can I apply the properties. So now let's apply the properties on different type of a question. So the same thing going for the log, it's going on the len or log, both of them are same property. So now let's start with the first express. Okay, express each logarithm in term len 2 and len 3. So your answer should be len 2 and len 3 together. Okay, so these two numbers together. Now the first question A, should be len 54. So 54, I need to express 54 in term 2 and 3. So first thing, len 54 is equal len 2 times 3. Okay, so from where can I get the 3 to the power of 3? It's from this way here. So 2 times 3 to the power of 3 is equal, 3 to the power of 3 is equal 27. 27 times 2 is equal 54. So now, after I convert the 54 into 2 times 3 to the power of 3, I can now add the property, the product property. So len with the 2, so len 2 plus len 3 to the power of 3. Then after that, I have a power product. So the power takes the 3 before the len. So this is what you can see here. So 3 len 3. So this is how can I simplify the question. Now let's do this one. The same thing. I need to write the 9 in term of 3. Okay, to the power of 2, and 8 can be written as 2 to the power of what? 2 to the power of 3. Okay, so now I can, let me change it, 3 to the power of 2 over 2 to the power of 3. Then I can use the quotient property. Quotient property means I take everyone minus len 3 to the power of 2 minus len 2 to the power of 3. Then I can use the power property, so it will be 2 len 3 minus 3 len 2. So this is the answer. Now how about this one? Express log 96, okay, in term of log 2 and log 3. So now log, okay, 96 can be written as log 2 times 3. So now I need to find the power. So if I test the power, I can know that 2 to the power of 5. Okay, so now let me write it. Log 2 to the power of 5 plus log 3. Okay, so I can now use the power property. So let me write it here. So we take the 5 before the log. So it will be 5 log 2, okay, plus log 3. Okay, now after we finish this one, try now to, it's your turn, try to solve this question. Let me show you the answer for all of them. After you solve them, check your answer. Okay, now let's go to the second example. So the second example, simplify logarithm. Same idea. Let's simplify the logarithm using the same rule that we learned, plus the property that we did last time. So as you can see, we have the root of 5. So don't forget this rule here that we wrote it before, n to the power of m. So we can write it a to the power of n, m over n. Okay, so now I can do this one here. This one is 5, this one here to the power of 1. So it will be 64 to the power 1 over 5. And 64, we need to change 64 to the same of the base. The base here is 4. So I have to change 64 to the 4 to the power of something. So I need to find the power, okay, in term to give you 64. So 4 to the power of what give you 64? It's 4 to the power of 3. So 4 times 4 times 4 is equal 64. Now let's multiply this one. If you look to this one here, this is power property. Power property means 3 times 1 over 5. So 3 times 1 over 5 is equal 3 over 5. Now use the power property again. So 3 over 5, we can take it before the log. So it will be 3 over 5 log 4. And don't forget, look, when I have base, same as the x, what's the answer? The answer is equal 1. So 3 over 5 times 1 is equal 3 over 5. Now let's solve this one together. Now let's apply the property, the power property. I have power here, we take it here before. So it will be 5 times 2 ln e minus, we do the same thing here. We take the 3 before, so 3 ln times e. Now let's multiply this, 10 ln e minus 3 ln e. Then ln e, we learned that ln e is equal what? Is equal 1, right? So now 10 times 1 minus 3. Also we know that ln e is equal what? Is equal 1. So 3 times 1. So now it will be 10 minus 3 is equal 7. Now let's do this. So let's convert it to exponential. So it will be log base 2, 32. All of that to the power of 1 over 3. Then let's change 32, okay, to become the same base 2 to the power of something. Log base 2 and 2 1 over 3. So I need to know the power of the 2 that can give me 32. So the power is 5. So 2 to the power of 5 equal 32. Now let's multiply with these 2. So log 2 and 2 to the power of 5 over 3 after we multiply 5 with 1 over 3. Then we apply the power property, so it will be 5 over 3 log base 2 times 2. Okay, now we know that when I have base, same as the x, so all of that term is equal what? Is equal 1. So 5 over 3 times 1 is equal 5 over 3. Now it's your turn. Try to multiply or to simplify this logarithm, and after you simplify them, check your answer from the answer key here. Now let's go to the next part. Example 3. Expand each expression. As you can see here, the previous question is asking simplify. Simplify, we need to find the final answer. Expand means we are not going to find a number. We are going to simplify the equation until the last step. So now expand each expression. So as you can see here, log 12 x to the power of 5, y to the power of negative 2. We know that 12 is multiplied with x, it's multiplied with y. So it's like this, 12 times x to the power of 5 times y to the power of negative 2. Now we know that this one is using the product property. The product property, I have to give the log for the 12 and log for the x and log for the y. So this is what you can see here. Log with the 12, log 12 plus log with the x, log x x to the power of 5. And look to the y, log to y to the power of negative 2. Now apply the power property. Log 12 stay same. Here I can take the 5 before the log, so it will be 5 log x. Negative 2 also can be before the log, so it will be negative 2 log y. So this is the final answer. Now let's expand this. So as you can see here, this is a fraction. Fraction means quotient property. So now let's do this one as a quotient property. So ln x square minus ln square root of 4x plus 1. Here I can use the power property, so I can take this one here. So it will be 2 ln x minus. Here it's a root, so I can do the root as a power root. So it will be ln 4x plus 1, all of that to the power of 1 over 2. Okay, now let's continue. Let me write here. So 2 ln x minus. Okay, 2 ln x minus. Now we can take the power before this one, so it will be 1 over 2 ln 4x plus 1. Okay, now can I simplify this one more? No, I can't simplify this one more, so this is the final answer. This is the simplest form that I can reach to. Now let's solve the last one here. So now as you can see, it's 4 multiplied with m cube multiplied with n to the power of 5. Okay, so now let's use the product property. So it will be ln 4 plus ln m to the power of 3 plus ln n to the power of 5. Now let's use the power property, sorry. So ln plus, we take the 3 before the ln, so it will be 3 ln m plus, we do the same thing with the 5, so it will be 5 ln n. Okay, so this is the simplest form that I can reach. Now you have here 2 questions, try to solve them by yourself, and if you need any help, please let me know. Okay, now let's go to the semi-last one, which is the condensed logarithm. Condensed logarithm, it's the opposite of the example 5, expand. So as you can see here, in the expand and condense, they are opposite to each other. So this one is opposite to this one here. What's that mean? That means in this equation, in the expand part, okay, in the expand part, I have the question, okay, in one term, and I need to expand it to make it more bigger. But in the condense is the opposite. Here he will give me the answer, okay, which is the longer one. So as you can see, this one is long, right? So in expand it was small, it become bigger. In condense it's bigger, and you need to find it in the small part, which means condense is the opposite term of the expand. Okay, so now expand, we have the question, we need to simplify. Here I have the simplified, I need to find the question. Okay, so this is the difference between them, just the opposite. Now let's start solve the first equation here. So look to the first equation, it's saying we have 4 log, okay, log base 3x minus 1 over 3 log base 3x plus 6. So let's apply now. Let's start from the let's say always start from the power property if you can find. So as you can see, this 4 here, I can rewrite it to the power of x. Okay, so reverse of the power property. So this is what you can see here. Then the same thing here, 1 over 3 also can be goes back to the power here. So it will be log base 3x plus 6 to the 1 over 3. And also in this term I can't simplify anything else, so it stays here. But here I can simplify. This is exponential. Can I write it as a root? Yes. So it will be cubic root for this one, cubic root of x. Now look to this one. I have this log here, okay, minus this log here. Minus means which property that I can use? It's a quotient property. So the quotient property, I have to take only the x's here and this term here. Okay, so it will be x to the power of 4 over cube root x plus 6, and don't forget log here. So this is what you see here. So log, okay, x to the power of 4 over cube root of x plus 6. Can I simplify this one more? Okay, what do you think? So see, look to what the book did here. So the book did something, we call it multiply with the reciprocal. What's the reciprocal means? Because if I have a question, if you remember, x over square root of x. So do you remember I told you before we can't have a square root in the denominator, or the book doesn't like to write the square root in the denominator. So how can I solve this equation? For example, let me give you easy one. 2 over square root of x. So how can I cancel the square root in the denominator? So I just multiply with the reciprocal. So I have to multiply square root here, square root here. So now I have to multiply the numerator with this and the denominator with this. So now 2 times square root of x is equal to square root of x. Square root of x, square root of x, they just cancel the square and they just write the x. So this is how you can simplify. Okay, so just now take the denominator, multiply the denominator with both of them, with the numerator and denominator, and simplify. This is what you have to do. Okay, let's do the same thing here. Let's do the same idea that we did here. Let's do it here. So the first step, the denominator is x cubed of root x plus 6. So now let's multiply the numerator with cube root x plus 6 over cube root, okay, with x plus 6. So the first thing here, we cancel now the cube root with the cube root, so it's remain only x plus 6. And here we just multiply these two together and put them next to each other. X to the power of 4 times x cubed. So this is the final and simplest form. Now let's do this second one here. Okay, so as you can see, we take the power, okay, and we put it the power root. And here also the power, it will be a power. So as you can see. And what's the operation between them? It's plus. So we have to multiply now x cubed multiply with x minus 4 to the power of 6. So this is what you can see here. Easy, right? So now let's do this one. As you can see here, I have a minus here. So what should I do with the negative part? The same thing. So negative here means negative 1, right? So the negative means negative 1. So we take this negative 1. Also, we multiply it with the power. So negative 1 times 2 is equal negative 2. So the question will be ln x to the power of negative 2 plus ln x plus 3. I can't simplify this term. Plus ln times x. Also, I can't simplify this term. Now, x to the power of negative, it can be to the denominator. So it will be what? Okay. So now as you can see, I have plus here and I have plus here. So now I can just add all of these, multiply all of these together. So which is the product property. So now let's take one ln and we multiply the first one, x minus 2, multiplied with the second one, x plus 3, multiplied with the third x, which is x. Now, don't forget this rule. When I have x to the power of minus number, the minus power can be written as 1 over x to the power of n. So now, because this one is a negative number, so it should be goes to the denominator. So it will be now ln, okay, x plus 3 multiplied with the x, all of that over what? X to the power of 2. So this term goes down using this rule. Now I have here x and I have here x squared. So I can cancel this x when I have two x's down. So I can cancel one x with the one x here. So it should remain 1x. So the final answer will be ln, okay, x plus 3 over x. So this is the final answer. I hope you understand this. Now try to solve this question by yourself. And if you need any help, please let me know. Let me just show you the answer. Check the answer key with your answer that you saw. Now the last one, the easy one, change of base formula. This term, when I told you, when let's say you can't evaluate or simplify the logarithm, okay, so you can use change of base. What is change of base means? Change of base when you have log bx, okay, for example, let me just give you a quick example. Log, okay, let's say the base is equal 5 and here is equal 6. How can you solve this? So you will tell me, teacher, okay, so I will first step you equal with y, okay, second step you write 5 to the power of y equal 6. Okay, then you need to change the number, the base of these to make it and find it and find the answer. But you can't simplify this because there is no base 6 to the power of something, okay, to be 5 to the power of y. No. So what you have to do, so we have to apply the change of base formula. What's the change of base formula? So change of base formula, you change the base for the log. So the base here is b. So what you have to do, you have to divide log a over log a. What is a? A is the new base. So you are going to change the base here to become as 10. So it will be log 10 over log 10. So you make both of them are the same base. But what you have to do with the b and the x will go to the numerator and b will go to the denominator. Okay, for example, let's go back here to this example. So now I have this question. What should I do? How can I solve it? So to solve this one, first step, you have to do log, okay, you take now the 6 over log, you take now the base 5, so you find the answer. That's it. So change of base is just to do log divided by log, and you take the x for the numerator and the base for the denominator. So this is what you can see here, and this is also what you can see here. It works for log and works for len. Now let's do some example to make sure you understand very well. So as you can see, the base here is 3, the x here is 5. So now the only thing that you have to do, log 3 base 3 5 equal len 5 over len 3. That's it. So this is what we can do here. So how can I solve this one? Do the same thing. First, let's do it as log. Sorry. Log 6 over log 1 over 2. Then use the calculator to find the answer. The same thing here. Log, okay, 8 over log 1 over 3. Then you can find the answer. See how the change of base easy? It's so easy when you reach to step that you can simplify the logarithm. Try now to solve this question and you can find the answer. Now to get the full power, try to solve the question from question 1 to 16 and from question 19 to question 58 on page 185. I hope you understand this. Have a good day. See you. Bye-bye.